Hello everybody. In this lesson, we will be talking about scalar multiplication. Scalar multiplication is multiplying a vector by a number. You might be thinking, how is that possible? Well, the result of multiplying a vector by a number is another vector, but it has been scaled by the number. As such, these numbers are called scalars, and I'll be referring to them as such in the future. Let's demonstrate scalar multiplication using this vector a. The value of vector a is 2, 1. As I said earlier, multiplying a vector by a number scales it, so let's see how the number 2 scales vector a. The number 2 will make the vector 2 times as long, scaling it by a factor of 2. This new, longer vector can be written as 2a. The value of 2a is 4, 2. For those of you that are paying close attention, you can see that the values of 2a are directly double the values of a. To show this more clearly, here is vector a written out as 2, 1. If we multiply each component by 2, you get 4, 2. Now we have two ways of showing and finding 2a. We can do it via the components of the vector itself, or we can show it graphically, making the x and y components 2 times larger than it was originally. Let's try another example. This time we will start numerically, and then do the graphical version. Let's take that same vector a and multiply it by -1 instead of 2. If we multiply each component of a by -1, you get -2, -1. This new vector can be written as -1a, or -a. If we draw this vector, it looks like this. Notice how the direction of the vector has changed this time to be the opposite of vector a. From this, we can deduce that when the scalar you are multiplying a vector by is negative, the direction flips in the opposite direction. Let's try a couple more examples before ending the video. Let's try and find the values and graph 1/2 a. Feel free to pause the video to try it out for yourself. By multiplying the components each by 1/2, you can see that the new vector is 1, 1/2, which can be written as 1/2 a. Graphically, the length of the vector has been halved. For our final example, let's do -3a. Pause now to try for yourself. Using multiplication, you get that -3a is -6, -3. Graphically, you can see that the vector has had its direction reversed and its length increased by 3 times. That concludes our video on scalar multiplication. Thank you for watching, and happy learning!